Sweet. Today we actually get to model real world data with sinusoidal functions. Try not to say that fast 3 times. So right now, if you have, I know exactly right. So right now, put this in your journal, okay? What we're going to do right now is we're going to use our graphing calculator. We're going to call January month number 1 and December month number 12. So what I want you to do is go to your graphing calculator right now. All right, there it is. Hit the stack button and press enter because we're going to edit. In the L1 column, I want you to go all the way to 12. 2, 3, 4, 5. I'm going to pause the video. That's how you just type it in. So when I unpause it, it'll be all the way to 12. So I'm typing from 1. It does go all the way down to 12. Now we got to do corresponding numbers. So January, what was the temperature? What, 32? Right? Then February, it went up to what? To 35? Right? Then 44. So I'm going to pause again. You got to write these corresponding temperatures in there. April was 53. Then it jumped all the way up to 63. Very nice. I'll pause it. All right. So now that we have all of this data, I'm going to go so you can see what I'm talking about. I basically made January to December and just typed in everything where? In the stat editor. Where do you go to do that? Hit stat and you press enter and there's all of my data. It's already entered. So now what we're going to do is we're going to create a window. All right? So go to window. I want your X minimum to be 0, even though technically the month we're going to start at is a 1. Okay, we're going to have X minimum 0. We're going to go all the way to a maximum of 12. All right, month number 12. Keep your X scale at a 1. Put your Y minimum, put it at 0. Okay? And then for your Y maximum, since the highest temperature was, what, 77, I think it was, the max temperature, type in an 80 for our Y max. Okay? So this is what your graph's going to look like right now. Oh, hold on. See all those little tick marks? Let's change our Y scale. Go to Y scale, put a Y scale of 10. Then all those tick marks will now be a lot better. All right, so here's what we have. We basically have 0 here all the way to 12. And we have 0 here all the way up to an 80. And this is 80 degrees Fahrenheit, and this is December right here. January would be right here, then February, and so on and so forth. So right now, here's what your graph looks like. Well, we're going to add some grids to it, so check it out. Let's add some grid lines. Go second, zoom. We're going to format it. Go to where it says grid lines and turn that sucker on. Now we can look at it, and there's what? Grid lines on our graph. Pretty sweet. All right, so now what we're going to do is we're going to actually plot the points. All right? Now, go to second, y equals, we're actually going to turn our stat plot on. Since we typed all those numbers in L1 and L2, press enter. Notice right here, what does it say our X list is? L1. What is our Y list? L2. We're going to turn it from off to on, so press enter so that it's blinking on. All right, now hit graph. It's really cool. Ta-da! There is your graph of all the points. All the points where? All the points where we plotted. Those numbers are now where? Right here. Now, it's kind of cool. Let's connect it. I know you guys can't do it on your calculator. But you see these points right here? What does this look like if I connected the dots? An anthill. Okay. All right. All right. Also, it looks like maybe a sine or a cosine function, right? Okay? But what we're going to do is we're going to interpret this as a sine function. I'm going to show you how to do it mathematically. All right? And then we're going to check to see how close we got it. So here we go. Look at our problem right here. It says find the what? Find the amplitude. So here's what I want you guys to do for answer choice A. All right? The amplitude, all right? Put amp for short, equals the absolute value of the highest number, okay, minus your lowest number divided by 2. So what is our highest number? 77. What's our lowest number? 32. Subtract those. All right? And let's think about this. We get a what? A 45 over 2. So that becomes a 22.5. That's our amplitude. Our amplitude is 22.5. All right, let's go back over here. It says find the vertical shift. All right, vertical shift. This is your D value. Okay, for D. D will always equal the highest. Now this is not, you don't have to worry about absolute value. The highest plus the lowest divided by 2. Put this in parentheses. All right, the highest plus the lowest divided by 2. So here we have what? We got 77 plus a 32. We're going to add those together and then divided by 2. Let's see, what does that give us? It gives us 109, right? Come on, forward. There we go. We get what? 109 divided by 2. So our D value is what? 54.5. Very good. Now, right now, what we're trying to create, everybody, all right? We're trying to create a graph that models after this. Y equals A sine, open parentheses, B theta minus C plus D. We're going to, right now, we have our A value, right? We have our D value. We still need to find our B and our C. What is the period of the sinusoidal function that models the monthly temperatures? Well, how many months do we have? 12. So the period, everybody, is 12. That's the period. I know that was really difficult, huh? So that's the period. Now listen, that's not the answer to B, because what's the formula for the period? The period is 2 pi over B, and we have to set it equal to 12 over 1, because our period is 12 months. So let's look at our cross products. What are our cross products? And Angela, you are a master of cross products. So tell me, one cross product. Go ahead. 2 pi's, right. Because 2 pi times 1 is 2 pi. What is the other cross product? 12b. You are right. So 12 times b is 12b. 2 times pi is 2 pi. What are we solving for here? We're solving for b. That's right. So what do we got to do to both sides? We're going to do something. Divide by 12. That's right. We're going to divide by 12 because we're solving for b. And 12 divided by 12 is 1. And 2 pi over 12 reduces to simply pi over 6, because 2 goes into 12. 6 times. Okay. So what's our b value equal to? Pi over 6. Now what we're doing is we're going to write down everything we have. Here we go. Y equals A sine, open parentheses, B theta minus C, close parentheses, plus D. What is our A value, everybody? It is? Got it. Sine. What's our B value? Pi over 6. We're going to put pi theta over 6 minus C, close parentheses, plus, what's our D value? 54.5. Very good. All right. Normally, to find C, we would use the formula for the phase shift. Okay? Now, the phase shift is always equal to C over B. And then we would plug in pi over 6 for B. But we don't know the phase shift. Okay? So what we're going to do is we're going to use our table. All right? So right now, look, right here, if I plug in a 1 in January, I plug in a 1 right here, what is the Y value when you plug in a 1? The temperature in January was what? 32 degrees. So we're going to use that information. So write this down. Instead of Y, put 32. Keep 22.5 the same. Now, if I plug in a 1 right here, that's going to give us just pi over 6. So if theta is equal to 1, 1 times pi over 6 is pi over 6 minus C plus 54.5. So far, so good? All we did was what? Plug in a 1 for January, because that's the month of January, and we got a 32. Now, we got to solve for C, everybody. So here's what we got to do. We got to take away 54.5 from both sides. Okay? It's supposed to be a 5. 32 minus 54.5 ends up getting, interestingly enough, negative 22.5, which equals 22.5 times the sine pi over 6 minus c. Now, once again, we're solving for what? We're solving for c. So, what I got to do next is I got to divide this side and this side by a 22.5. And here's what you get. You get negative 1 equals sine of pi over 6 minus c. So we're working our way closer and closer and closer to the value of c. Now here's my problem. The problem is that says sine and I don't want it there anymore. So what you have to do is you got to multiply this side by what's known as the inverse of sine, which means I got to multiply this side by the inverse of sine. Now what does the inverse of sine do? It cancels out sine. So here's what you're left with. You're left with the inverse of sine of negative 1 equals pi over 6 minus c. So just remember, when I say inverse of sine, everybody, the inverse of sine means 1 over sine. And 1 over sine cancels out that. So understand that's the process. Now, understand, in the graphing calculator, we got to be in radians mode. And there's going to be an approximate value for this. Okay? So watch what happens. Right now, I'm going to hit second mode to get back here. I want you to hit second sine and type in a negative 1 and press enter. And that gives you a decimal. Okay? Now, if you go back to what's called your unit circle, the sine of theta is equal to y over r. Alright? So where is my y value right here equal to a negative 1? Not my x value. Where's my y value equal to a negative 1? You guys see right here? At 3 pi over 2, it's equal to a negative 1. So, where is sine of theta equal to a negative 1? You could say that's where? At 3 pi over 2. That's if I started where? I started here, and I rotated which direction? I rotated right here to a 3 pi over 2. Well, what if I went this way and I went not counterclockwise, but I went clockwise? How far have I traveled from here to here? I've actually traveled negative pi over 2. So right here, see how I've traveled negative pi over 2? Now, here's what I want you to think about. The cool thing about this is watch. Negative pi divided by 2 equals what? The exact same approximate value. So right now, what I want us to do is I want us to go back to our information that we're working on, all right? And right here, I want you to understand, even though that's equal to a negative 1.57, I want you to change it to negative pi over 2 equals pi over 6 minus c. All right, to solve for c next, I got to take away pi over 6 and take away pi over 6. So that zeroes out. All right, I'm left with a negative c, bring it down, equals whatever this is. Well, they don't have like denominators, so I got to create a like denominator. So I'm going to create a denominator of 6. 2 times 3 equals 6. So the numerator would have to be a negative 3 pi. Change this to denominators that have the exact same. Okay, so negative 3 pi over 6 equals negative pi over 2. I don't know why my board's messing up. There we go. Now, if we add those together, you get negative 4 pi over 6. So here's what you're left with. The negatives cancel out, so c will equal 4 pi over 6, which reduces to 2 pi over 3. And we just found our c value. Here is your final formula with everything plugged in, where we took the value for c and we plugged it in right there. All right? This was our a value. This was our b value. This is our c value and our d value. Now we're going to plug it into our graphing calculator. So I hit y equals, and I typed in my big, long equation. X is theta. All right? I typed in everything as it appears, and I'm going to hit graph. There's our function, and here's the midline being drawn in. Here's your graph of your sine wave. There's your midline.